In this video, we're going to get an introduction to a new concept called a limit. As you can see, I drew a little diagram so that we could get a better understanding of what part the limit plays in our study of calculus. Up to this point in mathematics, you can say everything you've done up to today, or up to this video, we can call pre-calculus mathematics. And there's a lot of applications for pre-calculus mathematics. Humans have been using pre-calculus mathematics to solve lots of problems. But there did come a point where the math that we had for pre-calculus mathematics didn't quite work. And there was a lot of problems we couldn't figure out. So calculus was developed. Now, in order to develop calculus, we have to have this concept of the limit process. So we're going to start looking at this limit process and how it works. Then, once we understand the limit process, we're going to use that to develop calculus. The best way to get an understanding of limits is to go through an example. And we're going to take our time through this example. So you are given f of x equals x squared minus 3x plus 2 all over x minus 2. Alright, so there's our function that we are given. So the first thing we're going to do is we're going to evaluate this function at x equals 2. So let's evaluate f of x at x equals 2. Or simply, what is f of 2? So we can do that quickly. We have 2 squared minus 3 times 2 plus 2. And then we're going to divide that by 2 minus 2. So let's see, 2 squared is 4. Minus 6 plus 2 all over 2 minus 2. And we quickly see that we're going to end up with 0 over 0. Alright, now this is a special, we know we can't divide by 0, and we always call that undefined. This is actually a more specific case. This isn't undefined, this is indeterminate. And that is also not allowed in mathematics. We can't determine what the answer to this is. Alright, so we have our function, we evaluate it at 2. At 2, it doesn't exist, it's indeterminate. Now let's go ahead and concentrate around this value 2 and see what the function, or how this function is behaving. Let's make a little chart. I might have to do this in 2 levels, but we're going to have x, and we're going to have f of x. And so we're going to evaluate this at 1, 1.5, 1.9, 1.99, 1.999, 2, 2.001, 2.01, and as I thought I'd run out of room, so I'm just going to continue down here. Uh, 2.1, 2.5, and 3. Alright, now we've already figured out at 2 it's indeterminate. So I'll put indeterminate. Kind of hard to fit in there. But we know it doesn't exist at that point. But notice how this chart is set up. 2 is between 1 and 3. And on this side, we're starting to get closer to 2. And on this side, we're starting to get closer to 2. So let's get out our calculators. And I mean, 1 and 3 we could probably do by hand, but we are going to have to use our calculators for most of this. So, let's look at 1. So you have 1 squared minus 3 times 1 plus 2. So that's 0 divided by 1 minus 2. And it's still 0. Easy enough. Alright, let's try 1.5. So we have 1.5 squared, and then we're going to subtract 3 times 1.5, and then add 2 to negative 0.25, and then we're going to divide that by 1.5 minus 2. And we get 0.5. Okay, so we're going to have to start doing this for all these values and entering them into our calculator. And that does take a while, so your calculator does have a nice operation in here, or a nice function that we can quicken this up. So watch how I put this into my calculator. First up here, you're going to see the y equals button. Okay, so I'm going to go ahead and hit that button. And so we have y1, y2, y3, y4. I'm going to go ahead and put this in y1, and I'm going to put this equation, x cubed minus 3x plus 2 over x minus 2, into my calculator. And you do have to be kind of careful how this gets entered, because calculators sometimes have a hard time. They do pay attention to PEMDAS, and sometimes we don't realize how many things we do in our brain. But anyways, I'm going to go ahead and put parentheses around the top. So I'm going to put an open parentheses. Now here's our x right here, x squared. I guess I should push that up. So what I hit was x squared minus 3x plus 2. I'm going to close parentheses, and I'm going to divide that by x minus 2. Alright, so I put my function into the calculator, into this y equals part. Alright, now I'm going to hit second quit. Now here's where it gets pretty neat. Now you have to kind of watch how I get there. I'm going to hit vars, this button, V-A-R-S. Now up here I have vars and y bars, so I want y bars, so I'm going to hit my arrow over to get to y bars. And then notice we have function, parametric, polar, and so forth, where we want a function, so I'm going to hit enter for 1. And notice I now have y1, y2, y3, y4. Now we put our function in y1, so I'm just going to go ahead and highlight y1 and enter it. And now there's y1. And we're going to test this out, so I'm going to put open parentheses, 1.5, close parentheses. Now when I hit enter, hopefully we get 0.5. And we do. So now that this is in our calculator, we don't have to go through this, putting each of these numbers into this. We can just use our y1. So I'm going to go back again. I got vars, over to y vars, function, y1, open parentheses, and the next one was 1.9. So that gave us 0.9. Okay. Let's do one more this way, and then I'll teach you another little trick. So we go vars, y vars, function, enter, y1, open parentheses, 1.99. And we get 0.99. Alright, now a lot of times if I have this already in here, there's this cool, down here, above the enter, you see this in blue, it's called entry. And if we hit entry, what's going to happen is our previous value, our previous entry is going to come in. So I'm going to hit second entry, and notice I have my y1 of 1.99, and now I want y1 of 1.99. That gives me 0.999. Alright, just for fun, let's see. Entry. 2 should be unhappy. Yeah, it's divide by 0. So you should get some kind of error message. Didn't like that at all. Let's try 2.001. And this is going to be 1.001. Let's go. This delete button sometimes comes in handy. 2.01. 1.01. Alright, over here we have 2.1. Entry 1.1. Next we have 2.5. 1.5. And finally we have 3.